Shall we get started? Where are others? Later. Okay. So we'll start with the concepts. We discussed about Kirchhoff's law yesterday, right? So we'll start with the problems based on it. So here is the first problem that we are going to see. So what we are supposed to do is determine the current in each branch of the network shown in figure 3.17. Just a minute. Okay. So we need to find the current in each branch of this network, right, using Kirchhoff's law, right? So as I told you yesterday, when you apply Kirchhoff's law, it is not like you're going to apply only one law. You need to apply both simultaneously. Vandi sir, who? Is asking for. Ask. और ये तो बाइक की क्या कर रहा हूँ बाइक किया அது காப்பி பண்ணிடு எவ்வளோ டைம் காட்டுது 19 சரி இது செகண்ட் பேட்ச்ல ரெக்கார்ட் பண்ணுவாங்க அந்த டைம் ஓகே so how to solve this? You observe in this problem, right, you have the network AB CD A, right? So what they have done in the problem is they have given how the currents are getting split. In general, they will not give you. Okay. So here observe there are how many cells? There are 2 cells. So network is slightly a complicated one where you can't reduce this to a simplified form and directly apply Ohm's law. Right. So we need to obviously go with Kirchhoff's law. For that, what we are going to do is there are 2 cells. No, one is of 10 volt and the other is of 5 volt. So you take the main current to start from the bigger voltage. So let the current be I1. So this I1 is traveling towards the junction A and it starts getting split into 2 different parts. Right? How does it get split as? It gets split as I2 and the next one will be I1 minus I2. Did you understand why it is I1 minus I2? Okay. It is I1 minus I2. Then this I2 is the one which is traveling towards D. Right? And this I1 minus I2 is traveling towards D. So from I1 minus I2 at this junction, let us say I3 is flowing in this direction. See, I'm just following the condition that they have given. Okay. So I'm explaining based on how they have solved it. It is up to you. You're free to choose. What I meant by you're free to choose is this I1 minus I2 is coming here, right? You can say that at junction B, I3 is getting split here and the remaining current is going upwards. But look at the way they have taken. What they have done is from B, at point B, there is a current I2 that is going towards it, right? That I2, they split it as, they didn't actually split it. So this I3 which is there, they took it as continuously flowing in this particular path. And I3 is getting combined with I2 to flow through this branch. So to put it simple, what does Kirchhoff's current law state? The current entering the junction will be equal to the total current entering the junction will be equal to the total current leaving the junction. Okay. So I1 is the current that is entering A. from I1, how much is the current that is getting split? I2 is going here, I1 minus I2 is going here. Am I clear with this? So this I2 is reaching B. Okay, that's the first point. This I1 minus I2 is coming here. From I1 minus I2, I3 is getting split. Let's say I1 minus I2 is, let's say 4 ampere. I don't know what is the value. 4 ampere. Out of 4 ampere, let's say 1 ampere is getting split here. What can you do? The remaining 3 should flow like this. No. Instead of we taking it like this, what they have done is this I2 is combined with this I3. So I3 is taken in this direction, right? So I2 and I3 are going towards this junction. So what will be the current leaving the junction? I2 plus I3. That is why they took this as I2 plus I3. Okay, now observe it fall in place. This I2 plus I3 is flowing here. From I2 plus I3, how much is the current that is getting split here? I1 is going in this direction. So what will be the current that will come down? I1 plus I2 minus I1. So I1 plus I2 is towards the junction. So positive. I1 is away from the junction. So negative. So I1 plus I2 minus I2 plus I3 minus I1 is the one which is flowing towards D. Now, if you add everywhere and see, it will be the same current. For example, if I take point D, how much is the current entering towards point D? I1 minus I2 and I2 plus I3 minus I1. Add these two. I1 and I1 will get cancelled. I2 and I2 will get cancelled. What is left out? I3, that is what is leaving this junction. Are you able to understand? So since they already gave it in the diagram, I'm forced to explain it like this. Okay, but as I told you in the beginning, you are free to choose. You are free to choose the current and the way you need it. For example, this will definitely be a negative value. This I2 plus I3 minus I1 will come out as a negative value because I1 is the main current. From the component of it, you are trying to remove the main current. It will definitely come out as negative value. The meaning of negative value is the direction in which you assume the current to flow is wrong. So after you solve the problem, if at all you get a negative value at the end, it means that the direction that you assumed in the diagram, even before you know the values, is wrong. Means instead of the current flowing like this, the current would actually flow in this direction. That is the meaning. Okay. C to D. See, C to here, did you understand from B to C how much the current flowing? I2 plus I3. At C, there is a current that is going away from it. How much is that? I1. I1, no. So I2 plus I3 is coming towards the junction. I1 is leaving the junction. So I2 plus I3, if you take it as positive, I1 if you take it as negative, what will be the total current? That's what I gave you the last statement, no? Algebraic sum. So when you take the algebraic sum, you need to take one as positive, other will be negative. So in this case, I'm saying that the current entering the junction is positive and the current leaving the junction is negative. Okay. So this is NCERT example 3.6. And this is a problem based on Kirchhoff's law. Okay. So this is our first step of application of KCL. The next step is applying KVL. For that, you observe how many unknowns are there. In this problem, how many unknowns are there? I1, I2, I3. So 3 unknowns, you need 3 loops. So to apply KVL, the first logic is number of unknowns is equal to number of loops that we need to consider. That is the first logic. Second is at least in one of the loops, there should be a cell. These are the 2 important conditions that you need to. So first thing is you need to check the number of unknowns. Number of unknowns will tell you the number of loops that you need to consider. Secondly, whenever you consider, let's say in this case, you need to consider 3 loops. At least in one loop, there should be cell. In the other loops, you can only have network of resistors also. For example, in this problem, you don't have anything of that sort. I'll just explain with this. See, for example, you look at this diagram, right? This is the next one we are going to do. You look at this diagram. I can take the loop AB. If I call this as D, for instance, I'll take it as ABDA is one loop. If you observe, is there any cell in it? No, that can be one loop. So ABDA can be one loop. Similarly, BCDB can be another loop. In that also there is no cell. Okay. What is the third loop we can consider? We can take ABCDA. Suppose this problem had three unknowns, you will need three loops. No. So you observe the way I took the loops. ABDA without cell, BCDB without cell. So I'm not allowed to take the third loop also as ABCDA because that is not having any cell. So the only option is I need to take it as ABC, this thing, and A. I'll give names to these parts. Are you able to understand what is the meaning of second statement that I gave you? Yes. Because if you do it without taking the cell into consideration, you ever get the answer. You will not get it. Okay. So tell me what are the loops that we can take here. If I take the loop AB CA, so I'm taking the loop AB CA. Okay. So when I go from A to B, then how many elements am I encountering? So it is only one passive element. So across this passive element, what should be the value of potential drop that we need to take into consideration? Current is I2, resistance is 4. So product of both, what is it? 4I2. So potential drop is V is equal to IR. So you will take 4I2, but what are we supposed to take? We need to take a minus sign. The logic is very simple. If you're walking in the direction of current, that is from higher to lower potential, it is negative. So yesterday I told you, no, you need to take it as H and L. Instead of that, what you can do is the simpler way is look at the direction of current. So when you're walking from A to B, you're walking in the direction of current. In the direction of current is considered to be negative. Is the point clear? So here it is going to be minus 4I2. Similarly, when you go from B to C, what is happening? So B to C, there is a resistor of 2 ohm. So how much is the potential drop? Minus 2 into I1 plus I2. Why did I take minus? Because again, we are going in the direction of current. Whereas when you go from C to A, so A to B is over. Observe, look at the way I'm solving it. I go from A to B, then I went from B to C. Now we are going from C to A so that it completes the loop. When we go from C to A, you have one passive element and one active element. So what is going to be the potential drop across the passive element? 1 into how much is the current flowing through it? I1. So minus or plus? Am I clear? So what about the potential source here? You're going from lower to higher. So it will be plus 10. So everything put together should be a 0. This is what Kirchhoff's voltage law states. So how many elements are there? 1, 2, 3, and 4. So how many terms should be there? 1, 2, 3, and 4. So number of elements in the loop will be equal to the number of terms in the mathematical equation. Am I clear with this? It should be I2 plus N. That's yeah. So did you understand? Right? Now I'll give you one loop. So first copy this, then write the equation for that loop and show it to me. Follow the order that I gave you. DCAD. Take the loop DCAD. I want you all to write the equation and show it to me. I1 is getting multiplied with 1 ohm. V is equal to, when there is cell, just write EMF. When there is a resistor, multiply that resistance value with current. Understood? DC AD. Anyone without? Shrikriti, you got it? You didn't write. Why? It's okay. Then I explain. No, I explain for ABC. Same logic. Ohm's law apply பண்ணமா current multiplied with ரெண்டே ரெண்டு தான் பார்க்கணும். You need to see whether it is a resistor or cell. Resistor இருந்தா you need to multiply the resistance value with current. If it is a cell, just write the EMF value. Minus plus ஒண்ணுமே இல்ல. இப்ப ABC I took the loop. No, that is the name of the loop. That is irrespective of the direction of current. So when I go from A to B, look at the way I'm moving. When I go from A to B, how am I moving? I'm moving in the direction of current. So in the direction of current, minus. When I go from B to C, I'm moving in the direction of current. So that is the minus. Understood? Whereas across the cell, I'm moving from lower to higher potential. That is why there is a plus. Now, can you try? Use the same logic for DCAB. Sorry, DCAD. Did you attend yesterday's class? Attended, no? You didn't understand the concept? See, when you go from D to C, okay? The reason I gave you is I wanted you to understand how to do without, sorry, when you go in the direction opposite to current also. So when you go from D to C, you are walking in the direction opposite to current. So you are walking across whom? Across a resistor. So whenever you overcome a resistor, all that you need to do is take that resistance value and multiply it with current. So how much is the current across this 2 ohm resistor? So 2 is the resistance value. I2 plus I3 minus I1 is the current value. Since you are walking in the direction opposite to current, you should take a plus. Okay. Similarly, when you go from C to A, so when you go from C to A, how many elements are you overcoming? 2, one active and one passive. So across the passive, what are you supposed to write? So minus 1 into I1. 1 is the resistance value, I1 is the current through it. What about the cell? Just the EMF plus 10. What about going from A to D? When you go from A to D, how much? Sum of everything put together should be a 0. That's all you need to do. Okay. So I gave you 2 loops, no? Since you need 3 loops, the third loop I'm leaving it open. Which loop do you want to take? So can you think of the loop ABDA? See, for example, if I call this as E, can you take it as ABEDA? Right. So if you take the loop ABEDA, how many elements are there? From A to B, there is 1. From B to D, there is 1. And from D to A, there is 1. So totally you should have 3 elements. And one more point is, when you write these kind of mathematical equations, there should be at least one term which is having opposite sign of that of others. For example, when you write this equation, if you write everything as negative, you're wrong. If you write everything as positive also, you're wrong. The reason is very simple. You cannot have sum of all negative numbers to be a 0, or you cannot have the sum of all positive numbers to be a 0. It should be a combination. That is why at least one term should have an opposite sign. Okay, that is another hint when you're writing these equations. Okay, now write it for ABEDA. It's very simple. 3 elements, 3 terms should come. ABEDA. So when you go from A to B, Catherine, you try. You tell me, what am I supposed to write? Correct. Minus how much? I2 multiplied with how much value? What is the resistance there? 4I2. Did you say 4? Okay, I didn't hear, sorry. So minus 4I2. When you go from B to D, it's not plus. When you go from B to D, you are walking from higher to lower potential. You are walking from positive to negative terminal. So it is minus 5. And when you go from D to A, you are walking A to B, B to E. See, A to B, B to E means this thing only. There is no element in between, no. So B to E and E to D put together will become B to D. Okay. Only across resistor you need to see the direction of current. Only across resistor you need to see the direction of current. Across the cell, you need to see whether you are moving from higher to lower potential or not. You're able to understand? So here this minus sign is coming because of the direction of current. Because what you're doing for resistor you are multiplying with current. That is why I told you in the direction of current and opposite. Whereas for a cell, you're not multiplying with current. What are you doing? You're directly writing the value. So for a cell, what are you supposed to do? You need to see whether you're moving from higher to lower or lower to higher. So in this case, you're moving from higher to lower. That is why a minus sign. Yesterday, I gave you that, no, H to L, right? Similarly, when you go from D to A, you are walking in the direction opposite to the current. So it will be plus 4 into I1 minus I2 is equal to 0. So basically, you have three unknowns, three equations, you need to solve them. That is mathematical part. Okay, that part I'm not going to concentrate today. So did you all understand how to write the equations? This is more important for me. Clear with this? Okay. So copy this and leave some space for you to solve this problem. Since this is an example problem, you already have the numbers in your textbook. You can have a look at it. Okay. Textbook problem. So if at all you want to make a note of this point as E, then you can write it down. Okay. I want to write. Clear? Shall I proceed? Okay. Listen to this. Now I want you to try this problem. This is also your textbook problem, but it is from exercise. Okay. So determine the current in each branch of the network shown in the figure. So if you observe in this problem, I told you, they'll not give you the current. In fact, they should not even give you the arrow marks also. They should only give you this diagram, and all that you need to do is you have to take everything into consideration. So this problem is comparatively simpler because what is that you have? You have only one cell, right? This can still be simplified into Ohm's law condition. You can still simplify it because see, these two, how are they? Parallel. These two are parallel. So the whole combination will be in parallel. Find the equivalent value that will be in series with this. Okay. But that's not the objective of this problem. So since you're asked to find the current in each branch, okay. Since there is one cell, what will you do? The first step is take the current supplied by this 10-volt battery to be I. So this I will flow towards A, and from there it will get split into two parts. Okay, I'll only orally tell you, you have to do it. So I is coming like this. If I take this to be I1, then how much will this be? I minus I1. So this I1 is traveling towards B. From here, let's say I2 is flowing down. Then how much will this current be? I1 is going here. From I1, I2 is going down. So how much will this current be? I1 minus I2. So is that registered? So concentrate. How much is the current in the branch B to D? How much did I say? I2. So I2 is coming here. What is the current in the branch A to D? I minus I1. So I minus I1 is coming here. I2 is coming down. So how much will be the current leaving? I minus I1 plus I2. Okay. So how much will be the current here? I minus I1 plus I2. How much is the current here? I1 minus I2. When you add both of them, you will see that I will come back. So whatever is the current that has left will come back. That is why I told it works on the principle of conservation of charge. Okay. So since I told you here, I want you all to write it. So draw this diagram and split the current in the way I told you. Let's see how much of you followed. Adada. 10th one. So page number, you know? Okay, what is the page number? 128. Okay. Problem number 11 or 10? 9. Okay. So it is the ninth problem in exercise. Page 128, problem number 9. What is the figure number? 3.19. Okay. 3.30. Okay. The current supplied by the battery is I, and it is getting split as I1 and I minus I1. So I1 is going here as I2, then how much is the current here? I1 minus I2. Right? I minus I1 is coming here. So how much will be the current here? I minus I1 plus I2. Okay. So I1 minus I2 is coming here. And I minus I1 plus I2 is coming here. What do you get cancelled? I1 and I1 are gone, I2 and I2 are gone. So the current will be Ix. So how much will the current that will flow? P, and that is leading. So having said this, if you look at this problem, if I take the loop, so what is the loop we can take? If I take the loop AB, BA, A to B is minus 10 into I1. When I go from B to B, correct, minus 5 into I2. When I go from B to A, plus 5 into everything together should be 0. Right. So observe how many passive elements are there? How many elements are there in the first place? 10 ohm, 5 ohm, and 5 ohm. So we have 3 resistors, 3 terms. So what is the other loop we can consider? We take BCDA. So when you take BCDA minus 5 into minus I1 plus I2. No. have the same starting VCDP will be plus 5I2 will be equal to, here it is. What is the next one? So in both the loops that you have taken, there should be at least one loop that has a cell. So CD, I'll take this as E and F. If I take the loop A, B, C, F, sorry, C, E, F, A. A, B, C, E, F, A. So when I go from A to B, so when you come from C to F, it is plus 10 minus 10I, correct? How many elements? 1, 2, 3, 4, 1, 2. Right. So these are the three equations. Three is sufficient here now. So what are three unknowns? I1, and I2. So once you find the value of I1, and I2, look at the question what they have asked. Determine the current in each branch of the network. So you will be able to tell what is the value of I. You will be able to tell what is I1. So since you know these two, you'll be able to tell what is I1 and I2. You can write the value of course. That's what they're expecting this one. Idea with this, right? Okay. So this is how Kirchhoff's law works. Okay. Shall I proceed to the next one? So the next topic that we are going to see is a relation between terminal potential, EMF, and internal resistance of a cell. So next topic is a relation between terminal potential, EMF, and internal resistance of a cell. So I take a cell with some internal resistance. I take this to be A and this to be B. Okay. So whenever you talk about a cell, right, there are two scenarios that are possible. For example, if you look at this, right, if you look at this, when you take this battery into consideration, when you connect it across an electrical circuit, right, when you connect it across, let's say, a bulb, the bulb will draw the power from it, meaning the cell is going to get discharged. It is giving away its energy to the bulb to glow, right? There is another possibility also, which is reverse, meaning this cell can draw energy from another cell. For example, there is a 1.5 volt battery. You can connect it across, let's say, a 5 volt battery and try to charge it. So in these two scenarios, what will happen is this cell has an EMF of 1.5 volt. If you remember, I told you yesterday, the moment you buy from the shop and come, you don't connect it across any device, then whatever is the value that is written on top of it is actually not the potential difference. It is the EMF, right? As soon as you connect it across any circuit, there will be a potential difference developed across it, which will generally be less, right? But there you will see a scenario where it will be more also. I'll tell you when it is, but mostly it will be less only. Because I'm not saying mostly it will be less only because of theoretical aspect, that depends on the usage. So as I told you, I'm going to discuss about the relation in two scenarios. One is when the cell is getting discharged, and the second is when the cell is getting charged. Okay. So the first condition is discharged. So when I say discharge, the current is going to flow away from the positive terminal. The current is going to flow away from the positive terminal. So if I say the potential of point A as VA and the potential of point B as VB, then VA minus VB is what is called as the terminal potential difference. If I take the EMF of the cell to be E, then E will be equal to EMF If I take the internal resistance to be smaller, then R is the internal resistance. So I'll take this VA minus VB as V itself. My job is to find the relation between V, E, and R. Okay. Observe what I'm going to do. If I look at the terminal A, it has a potential of VA. And VA is on the side of the positive terminal. So VA will definitely be at a higher potential compared to VB. Right. So I'm going to apply Kirchhoff's voltage law here, but for an open circuit, look at the way I'm going to write. So if I start from this point, I'm starting with an energy of VA. Okay. Then I am walking across the cell. So across the cell, I'm walking from higher to lower potential. Means I will lose my energy by E. So what did I do? I started from here with certain amount of energy. So when I crossed the cell, I lost some energy of E. And when I walk across this resistor, I will gain some energy of I into R. Why is it so? Because I'm walking in the direction opposite to current. Right? So what did I do? I started from here, lost some energy here, gained some energy here. After doing all these things, I landed at point B. Right? So after all this sequence of events, I will be left out with some energy at point B. So this is how you need to apply Kirchhoff's voltage law for an open circuit. So what will you do? You will start from a particular point, then you will see whether you're losing or gaining energy, and that all that process should be equated to the energy that is left out at the final point. That is VB. Now, all that you need to do is rearrange the equation. VA minus VB will be equal to, E will go to the other side as plus E, minus goes to the other side as plus, and plus will go to the other side as minus. So this VA minus VB is what is E, and this V is equal to E minus IR. So this is the equation I gave you yesterday. So V is equal to E minus IR. Clear with this? So make a note of it. Yeah. Shall I proceed? Let me know once you're done. Shall I proceed? Okay. So let us see a problem that is based on discharging of a cell. So here there is a question. There is a battery of EMF 10 volt and internal resistance of 3 ohm is connected to a resistor. So there is a battery of EMF 10 volt and internal resistance of 3 ohm, which is connected across a resistor like this. If the current in the circuit is 0.5 ampere, so the current that is flowing through the circuit is 0.5 ampere, there are two parts in the question. What is the resistance of the resistor and what is the terminal voltage of the battery when the circuit is closed? So if you take this battery, what is going to be the terminal voltage? Right? It is very simple. So first I'll calculate the second part. What is the EMF here? 10 volt. Internal resistance is 3 ohm, right? And current is 0.5 ampere. So we know the relation between all these three in terms of terminal potential difference. So V will be equal to E minus I into R. E is how much? 10 minus I is how much? 0.5 is half into R is 3. So half into 3 is 1.5. 10 minus 1.5 will give you 8.5 volt. Meaning, when you get this battery, it will be written as 10 volt on top of it. But when you connect it across a circuit, it will only show 8.5 volt. Why is it so? Because it is getting discharged and there is some internal resistance also present. Okay. So this is the terminal potential difference across the battery. Right. So now the first part of the question is very simple again. All that we need to find is what is the resistance here. Since there is only one cell and this problem is simple for us to solve because you can reduce the total resistance to one value. How is it so? You can say that this capital R is connected to this 3 ohm in series. So what will be the value of equivalent resistance of this network? It is going to be R plus 3. What is the current that is already flowing through it? 0.5 ampere. Now, what is going to be the potential difference in this scenario? It will only be 10 volt. Don't take 8.5. You should take it as 10 volt because I already combined that 3 ohm resistor with the capital R. Now I am treating the cell to be an ideal cell. Now I'll apply V is equal to I into R. When I do this, what will I get? 10 will be equal to I is half into, this is going to be R plus 3, 20. So 20 minus 3 is going to give you 17. So the resistance that you have connected here is 17 ohm. Is the point clear? Right? So make a note of this. Unit. Unit. Clear with this? Shall I proceed? Right. So now we need to see the reverse scenario. That is when the cell is getting charged. So when can you charge a cell? If suppose this is a cell with some internal resistance R and its EMF is E. Let me say the potential of this point is VA and here it is VB. So when the cell is getting charged, in which direction will the current flow? So it will be towards a positive terminal. So looking at a diagram, you can say whether they're talking about the cell getting charged or discharged. If it is discharged, the current will be always away from the positive terminal. If it is towards, it is getting charged. Okay. So the same logic again. I'm starting at point A with an energy of VA. I am walking across the cell and losing an energy of E. And after that, I'm losing some more energy of I into R. And I'm left out with energy VB. So all that you need to do is bring VB to the left hand side, take everything to the right hand side. So is there anyone having doubt in this? Is everyone clear? Not clear. See, start from VA. When you go here, you're walking from higher to lower potential. So you're losing energy. That is why minus E. Across the resistor, you're walking in the direction of current. Means again, you're walking from higher to lower potential. So that is why you're losing an energy of minus IR. This will be equal to the energy that is left out at this point, which is VB. Okay. So if you rearrange it, VA minus VB will be equal to E plus IR. So the terminal potential difference here is going to be E plus IR. So unlike the previous scenario, here it will be the sum of those two values. So in the case of charging, what will happen is the terminal potential difference will be greater than the EMF. So during the case of charging, V is greater than E, whereas in the case of discharging, V is always less than E. Is this point clear? Yeah. Shall I proceed? So we'll see a problem that is based on charging a battery. So there is also a NCERT problem only. There is a storage battery of EMF 8 volt. So there is a storage battery of EMF 8 volt. And how much is the internal resistance? 0.5 ohm. It is being charged by a 120 volt DC source. So whenever you're saying charging, no, the positive terminal should be connected to the positive terminal. Okay. Am I clear with this? Now listen. So how much is this battery? This is 120 volt and it is charged using a series resistor of 15.5 ohm. Okay. Now, what is the terminal voltage of the battery during charging? So here there are two batteries. Now, which battery are they asking? This one. Because they didn't use the word battery, it is some supply. They would have used the word supply there. So what is the terminal potential difference across the battery means? They are asking across this 8 volt battery. Right. So even before we solve, we know the formula. What is it supposed to be? V should be equal to E plus IR because it is getting charged. So current is flowing in this direction, obviously. right? It is going to be 8 plus I into half. So it should be 8 plus I into half. So what is our objective in this problem? To find the value of I. So to find I, what we'll do is we'll combine these two cells and write it as a single cell. Okay. Now understand. Here, this 120 volt is supplying current in the anti-clockwise direction. This 8 volt will also try to supply current in the opposite direction. So are you able to understand? Meaning of this is, let me tell you. If I take this cell, this is the one which I'm trying to charge. If I take the positive terminal of this and connect it across the negative terminal here, then what will happen is these two voltages will get added because both are supporting each other. Are you able to understand? What do I mean by supporting each other? This is supplying current from positive terminal. This is also supplying the current in the same direction. So they both are complementing each other. So when I put these two things together, what will happen is this 1.5 volt and this 1.5 volt will get added. Whereas if I put them in reverse like this, what will happen? This will supply current in this direction, and this will also supply current in the opposite direction. So unfortunately, they both are of same potential, same EMF. The whole effect will get nullified. Of zero EMF. Are you able to understand? So when a positive terminal and here observe, positive is connected to positive. What will happen? They'll get subtracted. So which one should get subtracted from the other? Obviously, which one will dominate among both? 120 will dominate compared to 8. So here the net EMF is no more going to be 120 or 8, rather it will be 120 minus 8. Am I clear with this? There's a very important point to be noted. This concept is called as cells in series and parallel, which I'll be discussing later. But as of now, could you understand what I'm trying to say? So it will come out to be 112 volt. Clear? So this circuit, if I redraw, it will be like a 112 volt cell connected across one resistor of value 15.5 plus 0.5. So what I'm doing is I am doing the net EMF. I am finding the net resistance also. So since these two are connected in series, what will be the net resistance? It will be 16 ohm. And the current will be I like this. Now it's a simplified circuit. You can apply Ohm's law. So I is equal to V by R, 112 divided by 16, and the answer will come out to be 7 ampere. Because 6 into 7 is 42, so the number 2 comes at the end. So it is going to be 7 ampere, right? Now our objective is to put the 7 here. So what will be the answer? Take the 7 and plug it here. Answer will be V is equal to 8 plus 7 into half is going to be 3.5. Answer will be 11.5 volt. Meaning the terminal potential difference across this 8 volt cell will not be less than it, it will be greater than it. And how much will be the value? It will be 11.5. Am I clear with this point? That is one thing. Secondly, they are asking, what is the purpose of having a series resistor in the charging circuit? Why can't we take this 120 volt and directly connect it to 8 volt and then charge it? If you do like that, there is a possibility that a large amount of current can flow through the circuit and it might spoil this 8 volt. So to control it, you need to add a series resistor in between. So are you able to understand? So you add a series resistor and not directly connect both the cells together, only to control the amount of current that is being flown to the other circuit. Other part of the circuit, rather, I would say. Is that point clear? Yes. So this is all about this problem. Okay. Clear with this? We'll stop with this for today. And cells in series parallel, Wheatstone bridge. I think there is one more concept here, power in an electrical circuit. These are the four concepts left out. So practice till here and come for the next class. So I'm ending the session.